Let's do an experiment which is very pretty that involves food color and wonderful patterns. It's very artistic. So before we do that, let's talk about this. I have some water and then oil in a cup. You all know water and oil don't mix with each other. When I ask students why do they not mix, what is the reason? One answer I get is always their densities are different. That's absolutely true. Oil is less dense, so it floats on top of water. But even if the densities are different, if we force them to mix it, they should actually mix it if the density is the only reason. But as you can see, when I just let them be and then they separate out again, oil goes off there and water here, they never really mix. Okay, because the actual reason they don't mix is their chemical property called polarity. Water is what's called a polar molecule. Polar means it's like having two poles. How a magnet has a pole, north pole and a south pole, water has poles in there. The oxygen atom in there has a negative charge, partial negative charge. Hydrogens have partial positive charges. So water has polar. Water has two poles basically. That's why it's called polar. Whereas oil is mostly made out of carbons and hydrogens. They are the same charges. There's like nearly no charge basically. So that is what is called non-polar. These two are like enemy camps and they do not mix. Not only they don't mix, if we know some other compound based off of where it dissolves, we can tell whether it's polar or non-polar. For example, if I add some salt into this mixture, you all know salt dissolves in water. Because salt goes to water, salt also is polar. But if I add something that's non-polar, that will go into oily layer here and dissolve it. Do you know any solid that dissolves in oil but doesn't dissolve in water? Think about it. If you can't think, even figure, if you can't have any answer, I'll tell you at the end of it, because it's a little bit hard to think about things that dissolve in oil but don't dissolve in water. So in the same vein, if we look at say milk, especially whole milk contains fat. This one has about 10% of fat. Fat is very similar to oil in its properties. And then milk also contains lots of water. So in a way, milk has fat and oil inside. But unlike this, you always see milk being very uniform. We don't see milk, fat going one way and water going one way. So what's holding those two things together inside the milk, whereas in here we don't see them together? Okay, so milk also contains a very important ingredient, which is actually protein. Protein is like a bridge between fat and oil. So fat and water, I'm sorry. So it actually holds these two together. What happens if I add something to the milk that takes away the protein? So let's see. So I'm taking some milk here, which is actually, you can see very uniform. No, you can't see any separation between water and fat. And because the protein is holding it together. What if the protein, I take away the protein from milk, water should go away one way and protein, the fat should go away another way. Let's see. How do we see the movement? In order to check the movement, let me add some food color. I'm just adding like a couple of drops and I'm not going to mix it. I will let the reaction do the mixing. Okay. Food color has no purpose. We're just adding it so it actually looks nicer. And then now here I have just a little soap here. This is just a regular soap solution. I've added some water to this to make it all, uniform. Now watch this. This is it's a very, very, very pretty reaction. All I need is drop one soap drop there. All the fat ran away to the sides. While it's running away, it actually took the color with it. And then I can actually move the color around using this. So do you see wherever this color accumulated, if we just add this, color keeps coming back to the middle. So this is kind of like an oil painting. So if you are an artist and looking for some inspiration to make like new paints, hopefully, maybe this inspires you. Okay. But the only problem is this will go away after some time. We cannot like fix it into a frame. How can I have it like, how can I at least like transfer it onto something? what I can do is I have a paper towel. So if I just dip it into it carefully, it is like a tie-dye. The pattern comes onto the paper, and you can see the one that is at the left in the cup also. It's so pretty, right? So this is called the milk rainbows experiment. So the same thing can be done with white glue instead of milk, and that dries out and comes out very, very pretty. I'll show you that maybe in another experiment. Now we have the oil and water. So the way when I added soap, it actually the protein was gone. So can I do something to this to mix them together? I know even if I shake them, they're not mixing, they're coming back together. There is a way to actually mix it. Again, add soap to that. If we add a bit of soap to that, and if I mix it, okay, we can see from the side also, it's kind of completely mixed. This actually has a special name. It is called an emulsion now. Anytime water and oil are mixed in, with not necessarily soap, something similar to soap, this is called an emulsion. So the paints that we use at home, the wall paints, they are called emulsion paints. Sometimes, you can see it on the paint can, because they cannot be polar or they cannot be non-polar. They're kind of in between. That's how we actually mix water and oil.